Okay, we've got the notes for section 2.8, solving inequalities in one variable. So we'll start with polynomial inequalities. So a polynomial inequality takes the form f of x is more than 0, greater than or equal to 0, is less than 0, or less than or equal to 0, or not equal to 0, or f of x is some polynomial. So to solve f of x greater than or equal to 0, is to find the values that make the graph of the function positive. If it's less than 0, you're finding the values that make the function negative. So example 1, let f of x equals x plus 3 times x squared plus 1 times x minus 4 squared. Determine the real values of x that cause f of x to be 0, to be positive, to be negative. So to be 0 is relatively straightforward. It's essentially just like solving the equation. So we take each factor separately, equal to 0, and we solve them. So this one's going to be negative 3. X squared is equal to negative 1, which has no solutions. And this one was x minus 4 equals 0. So when I take the square root of both sides, square root of 0 is still 0. So x equals 4. So there we go. There's part A. So a negative 3 and a 4. Now, the easiest way to do the rest of it is to do what's called a sign chart. So we're going to mark our zeros here and here. And then we can choose values from each section and plug them into the original to see whether we get a positive or a negative value. So the easiest one to do here is x is 0. So if I plug 0 in for x, I get 3 squared times 1 times negative 4 squared. So that's 9 times 1 times 16, which is a positive number. I don't actually care what the number is. I just know whether it's positive or negative. Now to get the other ones, so some number more than 4, some number less than negative 3, we can plug numbers in. So for example, if I plug 5 in, this becomes 8 times 26 times 1, which is a positive number. If I plug negative 4 in, I get negative 1 times 17 times 64, which is a negative number. The other ways, if you remember, are a multiplicity trick. This number here at 4 has a multiplicity of 2 because it's squared, which means the sign does not change across that value. So if it was positive here, it has to be positive here because the sign can't change. Negative 3 has a multiplicity of 1 because it's x plus 3 to the first. So the sign has to change across that 0. So if it's positive to the right, it has to be negative to the left. So if you use your multiplicity tricks, you can also get the pattern with only having to solve for one section. All right, so example 2 asks us to do a similar thing, except it does not give us the factors. So solve analytically. So let's see here. So we'll start with our actually p's and our q's. So p's, the factors of 24, 1, 2, 3, 4, 6, 8. 8 times 3, 2 times 12, 24. Q is the factors of 2, 1 and 2. So you're going to get a whole host of these that I don't really feel like writing down. But if you use your graph, one that definitely will work is 4. So we know 4 is a 0. So coefficients 2, negative 7, negative 10, 24. So the 2 comes down, that's 8, which is 1, which is 4, which is negative 6, which is negative 24, which is 0. So this is 2x squared plus x minus 6, which is a quadratic. So I can do the quadratic formula on it to find its zeros. So let's see here. So that's negative b plus or minus the square root of b squared minus 4ac is going to be 48. 4 times 2 times 6 becomes plus here because the 6 is negative. Over 2a is 4. So that's negative 1 plus or minus the square root of 49 over 4, which is negative 1 plus or minus 7 over 4. So negative 1 plus 7 is 6 fourths. So 3 halves is the solution. 6 over 4 reduced. Negative 1 minus 7 is negative 8, so negative 2, and then our original 4. So go to my number line. So in order, least to greatest, so negative 2 is the smallest. Then we've got 3 halves, Then we've got 4. So x equals 0 is the easiest one to check, falls in here. So when x is 0, if I plug 0 into my equation, I get 0 minus 0 minus 0 plus 24. So this section is positive. Since 3 halves has a multiplicity of 1, it occurs once, the sign has to change, meaning that section is negative. Since 4 has a multiplicity of 1, sign has to change across it, so that's positive, and over here, also negative. So where is it positive? Well, it's positive between -2 and 3 halves. That's that section, or more than 4. No brackets at the 4s in the numbers because at 4, 3 halves and -2, it's equal to 0. It's not greater than 0 anymore. But that would be your solution. Okay, solve graphically. So let's look at the graph. So the first thing we need to do, if we're going to graph it, is to get everybody on one side of the equation. So to do that, so we've got x cubed minus 6x squared less than equal to minus 8x. So these two guys on the right need to come left. So x cubed minus 6x squared plus 8x minus 2 less than equal 0. So let's look at the graph of this thing. All right, x cubed minus 6x squared plus 8x minus 2, draw. Let's reset our window here. There we go. So G-solve, the roots are negative 0.3, so that's like here. About 1.5, so right here. And the last one is at 4.2, so about here. It does something like this. You don't have to be very exact, you just need the shape. So since I arranged it to be less than or equal to 0, I need where it's below the x-axis. So that's this chunk here, which that first 0, we'll copy them down again. So my zeros were, whoops, the camera, 0.32. There was the second one was at 1.46, and the last one was at 4.21. So it's anything left of this value, so x less than 0.32, or anything between these two. So 1.46 less than x, or at least should be less than or equal to, because I can equal 0, 4.21. So that'd be inequality notation. An interval notation, that would look like this. So less than 0.32, and between 1.46 and 4.21. That's some squared brackets because they are the or equal to's. Okay, so you can also have rational inequalities. So let r of x equal this equation, determine the real number of values of x, cause r of x to be 0 versus undefined, then make a sign chart, determine the real number of values of x that cause it to be positive or negative. So let's recopy r of x here as an actual fraction, 2x plus 1 over x plus 3, x minus 1. So that's my expression. So what I need to do is find the zeros, and the undefined. So the zeros occur whenever the numerator is 0. So 2x plus 1 is equal to 0. So 2x is equal to -1. So x is -1/2. Undefineds occur when the denominator is 0. So x plus 3 times x minus 1 is 0. So this essentially is factored, so break them apart. Whoops. -1 equals 0, so x could be -3 or x could be 1. Now for rationals, when you redo our sign chart, you plot the zeros and the undefined values. So -3 is the smallest, and we've got -0.5, then we've got +1. And then we choose values from each section to determine whether the graph is positive or negative. So this one part will cover C and D. So easiest one is 0, which lies here. We need some number more than 1, like 2, between -0.5 and -3 like -1, and something less than -3 like -4. Now, since -0.5 is a 0, we can use the multiplicity rule to go across it. So it has to be opposite, but that's not necessarily true at the undefines. So we'll just go ahead and check them all. So when x is 0, I'm just going to actually write the signs down here. So when x is 0, the numerator is positive, the denominator is a positive times a negative, so this whole thing is a negative section. When x is 2, the numerator is positive, the denominator is a positive times a positive, so this section is positive. When x is -1, the numerator is negative, means this becomes -2 plus 1. This section will still be positive, and this section will be negative, so that's a double negative, so that section is positive. And then when x is -4, it's negative on top. On bottom, it's negative first and negative second, so this whole thing is negative. So if you need to write so for C, where is the graph positive? Well, it's positive between -3 and -0.5, and anything more than 1. So for D, where is it negative? Well, it's negative anywhere less than -3. So -3, -infinity, and between -0.5 and +1. Now notice no square brackets because I don't have an or equal to. 0 isn't a positive number or a negative number. And in any case, these two values, -3 and 1, you cannot exist at those values. The function doesn't exist, so you could never have a squared bracket at these two numbers anyway. -0.5 is the only one that potentially would have a squared bracket at it. Okay, so example 5, solve 5 over x plus 3 plus 3 over x minus 1 less than 0. So what we need to do is common denominator of this problem and turn it into a single rational expression, so we can do undefines and whatnot. So let's rewrite it here so I have room to work. So to get common denominator, you multiply by the other denominator. So this one needs an x minus 1. You have to do it on the top and bottom to keep it equal to 1. This one needs an x plus 3 on top and bottom to keep it equal. So on top here, I've got 5x minus 5. On bottom, x minus 1 times x plus 3. Plus over here, I've got 3x plus 9, so distributing over x minus 1, x plus 3, less than 0. So combining like terms, that gives me 8x, 5x plus 3x, and then this one gives me minus 4. Nope, plus 4. So x minus 1, x plus 3. So my zeros and my undefines. So my zeros occur at 8x plus 4 is equal to 0. So 8x equals -4, x is -0.5. My undefines are at 1 and are at -3. So sign chart. If you notice, this problem should look real familiar because we just did it. So undefines here at 1 and at -3. So the trick is this guy here is just a multiplier of the one we just did. It's 4 times bigger, which means the signs aren't going to change. Negative, positive, negative, positive. So where is it less than 0? Between anything less than -3 and between 1/2 and 1. So those two pieces. You could do the sign chart again if you wanted to plug in some value. So choose like x equals 1 or 0, 2, whatever, but you'll get the same thing because that is just 4 times bigger. So this is 4 times as positive as that one is. That's 4 times as negative as that one is. Okay, so turn the page over here. So now we've got some rationals in it, or radicals, sorry. Solve x minus 3 and then square root of x plus 1 is greater than 0. So let's see here. So 0's first. So you've got two factors, so you set them separately equal to 0. So this one's going to give me 3. This one's giving me x plus 1 equals 0, so square both sides. X is equal to -1. So sign chart, -1, 3. So let's see here. 0 falls in here, so we'll do 0, we'll do 4, we'll do -2. So when x is 0, my expression becomes a negative number times a positive number, which is negative. When x is 4, I get a positive number times a positive number, so that's positive. And when x is -2, I get a negative number times an undefined value. So if I plug -2 in, I get the square root of -1, which is not allowed. So this graph actually doesn't exist over here. So if I want it greater than or equal to 0, well, 3 was a 0, so I can count. So it'd be anything more than 3 would be my solution. No, whoops, there is actually one other thing. How to write this best, because -1 also counts. If you need to write just a single value, you use braces. So -1 and the interval like this. I suppose if you really wanted to, you could do bracket -1, comma -1, but an inequality thing doesn't work that way. All right, example 7, solve this guy. So I need my zeros, I need my undefines. So to do the zeros, let's see here. I take my numerator, so x minus 2 is equal to 0. To get my undefines, I set my denominator equal to 0. So x is 2. Over here, normally when you drop the absolute value bars, you get 2 equations, one with the actual version of this and one with this negative, but since 0 is its own opposite, you only have to solve it once. So you get that. Technically, the other equation looks like this, but -0 doesn't mean anything, so you don't have to worry about it. So on my number line, -3, 2. So these guys are solutions because they are or equal to 0. So let's see here. So 0 lies here, some number more than 2 like 3, some number less than -3 like -4. So we'll do our little sign charts. So when x is 3, I get a positive on top and I get a positive on bottom, so this section is positive. When x is 0, I get a negative on top and a positive on bottom, so this section is negative. When I do -4, I get a negative on top and a positive on the bottom. If you notice, the bottoms are always positive because I'm taking an absolute value, so I actually don't even have to worry about the math, which is negative. So where is this graph less than or equal to 0? So it does look like there's 2 sections, but since -3 bridges and -3 counts, I can just do everything less than 2, including 2, because it is actually equal to 0 at 2. So there you go. Open up. I lied. Oops, that's an undefined, so I can't do that. I can't bridge them. So I have to break it into 2 pieces. So from -infinity up to -3, and then picking up again from -3 to 2 can get a bracket because it's actually a solution. So -3 should have an open dot, so I can't include it. I have to break the graph there at -3. Okay, example 8. So Dixie Packaging Company has contracted with another firm to design boxes of a volume of at least 600 cubic inches. Squares are still to be cut. Oh, so we got cardboard, flaps filled up. What size squares should be cut from the cardboard? So real quick sketch. So we're going to cut corners out. So we've got 20 by 25, and when we fold it up, it's going to make a box. That's x units tall. That's 25 minus 2x wide. And is 20 minus 2x deep, so the volume of this box is 25 minus 2x times 20 minus 2x times x. And I need that to be at least, so that's greater than or equal to 600, because that's the least value allowed. So I set all of this stuff, so 25 minus 2x, 20 minus 2x, and x greater than or equal to 600. So I can algebra this out if I really wanted to, distribute FOIL, and then solve it. Or I can actually look at the graph. So what I'm actually going to do is, graph. So I need to graph my left and right hand side separately. So 25 minus 2x, 20 minus 2x times x. So that's the volume of the box. And the second equation is just going to be the number, 600. So if you notice, nothing shows up because my zoom is crazy, so zoom auto. So that parabola shape is the volume side, the straight line is the 600. So I need to know when is it more than 600. So I need to find where those two lines cross each other, and it's going to have to be in between them because that's where the curve is above the horizontal line. So on a Casio, that's G-solve intersection. So the smallest value is at x equals 1.66, and the largest value is at x equals 6.16. So any cuts in between those two values will give me the box volume of at least 600. Right. Yep, just making sure. So that's the solution. I can make any cut in there and have the volume be 600, at least 600. At the two endpoints, it's exactly 600. In between them, it's going to be more than, but the question doesn't give me a specific value. Alrighty, last example. This one should be familiar. Surface area is less than 1,000. So the volume is of a right circular cylinder is pi r squared h, and that has to be 2,000 cubic centimeters. The surface area of a can is pi r squared, 2 pi r squared, that's the end caps, plus 2 pi r h, that's the sides. So surface area is less than 1,000. So if you remember, we need to solve this guy. So I'm going to solve it for h. So let's see here. Over pi r squared. And then that h is going to go in here. So the surface area is less than 1,000. So 2 pi r squared plus 2 pi r, and h is actually 2,000 over pi r squared, has to be less than 1,000. So 2 pi r squared plus 4,000 over r is less than 1,000. So I'm going to use the graphing method again. I'm going to graph the left and right hand sides separately. So if I put the left hand side into my calculator, let's see if I can get it all on the screen at once. That'll do. So 2 pi x squared plus 400,000 over x. So that's the equation side, and 1,000 over here. Draw. Zoom auto. G-solve intersections. So there's one there at 4.6. And there is another one at can't see enough of the graph. There's two of them. Zoom out. G-solve intersections. So at 4.6, so the radius has to be 4.62, and the other one from my calculator is 9.65, so I have to be between those two numbers for the radiuses. Yep. And then the height's kind of tricky because you can't necessarily build an interval, but you can just make the statement that the height has to be 2,000 over pi r squared, just because whatever this r value is would have to get plugged in here to calculate the height. But you could find essentially the height that goes here and the height that goes here if you wanted to, but the heights will range between those as these range. So let's actually figure out what they are. 2,000 divided by pi divided by 4.62 squared. So the 29.83. Actually, these are going to be backwards. It's going to be 29.83 at the top, because if the radius is small, the height has to be big. And then if I change this to 9.65, I get 6.84. So the height will have to range between those values. And I did make a mistake. These should be parentheses, not brackets. Because if they're brackets, that'll mean I'm going to equal 1,000 on the surface area, and I do not want it to equal to. I want it to be less than. But that brings us to the end of this section.